I read a book. What inspires you? What motivates you to be something in life? Where you're going to go? And I just read a book. I was very young. Hand radio operators typing on Morse code keys, signals to each other in another city. And I thought, wow, you get to another city, another state. That's like Superman stuff. And you can get a ham radio license, it said at the end of the book. Anybody can, any age. You didn't have to be 16 years old, like to drive a car. And I ordered the information, I studied a lot of formulas of electronics and learned a lot of things, and I got my ham radio license. So I was kind of all alone. I couldn't tell anybody. Nobody else knew what it was about. I remember going to an event once and holding up a sign saying, ham radio operators of Sarah School unanimously support blah, blah, blah for some officer. 20 cameras fired, and they printed the picture the next day on the front page of the San Jose Mercury saying Steve Wozniak representing a school group. It was a joke. And all my life I find that a lot of times when you joke, well, people take it as real and literal. And sometimes it causes me a problem. But anyway, it was exciting. Electronics was different because you could actually hook a few wires together, build a few things, afford to buy a few parts down at Sunnyvale Electronics and wire them together and make little tone makers that did strange things. So it was a great growing up experience. I had electronics kids as my friends. Their parents were engineers. They had access to parts. They liked reading magazines and seeing little things you could build that maybe make a siren sound. So this was a fun existence for us. And I was kind of always the leader of those little kids. I was like the only one that got the top math student in school and that kind of stuff. And we built a house-to-house intercom. We just came across some wire, we laid it out, we ran down to Sunnyvale Electronics, bought some microphones, carbon microphones, we bought some speakers and batteries, and we had this little intercom from house to house up the block, and I had an amazing learning experience, that was more real than reading about something in a book. Because nobody told us to build this intercom. Our parents didn't suggest it. They didn't even know we were doing it. We did it secretly. We ran the wire down the fence, the wooden fence. Of course, one of the neighbors had cut the wire into about 50 pieces, so we learned to run it on the other side of the fence. And like I said, we just did this all on our own, and we had to solve problems on our own. One time I was going to actually use my Morse code key to try to talk to a guy far up the block, and I heard him in my speaker, where I was going to hear da-da-da-da-da-da-da. I heard his voice. And what? It was really weak. And I shouted in my speaker, and he heard me. And we discovered, at a very young age, without reading it in a book, that a speaker is also a microphone. You put electricity into a speaker, it makes a sound. You put a sound into a speaker, it makes electricity that goes down the wire. Wow, that's something that's so solid a way to learn things. When you learn them on your own, or you have a personal reason, some personal involvement in it. When something matters to you, and it's not just getting a grade, it's not just getting a salary, it's not getting a stock option or an award or a title in a company, those are the things that push you the hardest and have the most meaning in your life, and you have emotional memories that come from them. After winning a lot of science fairs, in high school I was a big prankster because I was so shy that I couldn't really talk to anybody, and sometimes the social energies come out in whatever way they can. And I learned that the way to pull pranks is don't tell anybody else you're doing it. Tell one other person, the word's all around, everybody's talking about it. Steve did it, and the teachers all know it, so I got away with everything in high school. Only one time, there was one incident where I decided I'd put an electronic metronome in a friend's locker. He was the only guy I knew his combination. And I put the electronic metronome in his locker going tick, tick, tick. So, yeah, so I was experience with the cops with wires hanging out of the box, and the principal, the vice principal, and the dean, and the counselor, and I kind of started laughing when the principal said how he opened up the locker, grabbed it to his chest, and ran out to the football field and dismantled it. And I had to cough to hide my laughter because I had a switch that when you opened up the locker, it started ticking faster. A prank can be a dummy prank, or it can be a little something special to it. Always adding that little specialness is important to me in all of my projects, electronics or pranks, my entire life. But my high school electronics teacher realized that I already knew all the electronics in the class, and all I was going to do was play pranks like trick people into wiring their TVs wrong so it would blow up. He got arranged for me to go down to a company once a week and program this thing called a computer. Wow, that was a special word when nobody had computers. And I went down, and the first big program I wrote was, once I learned how to do it, how to type in some punch cards and read them into this computer, I wrote a program called the Knight's Tour of Chess, where a knight tries to hit every square of the chessboard exactly once. And my program would go 1,000,000 times a second. This computer could do things. A human being can't do one thing a second, hardly. This computer could do 1,000,000 a second. Wow. And it bounced the knight piece around, and when it got stuck, it backed up and tried a different route, and backed up and tried a different route. Nothing came out for 5 minutes, 10 minutes, 15 minutes. And, I went back home and I studied my program. I figured out it was working correctly, but it was going to take 10 to the 25th years.
Wow.
What that meant was the brute force of a fast computer that could do 1,000,000 things a second couldn't solve a problem. You had to have a better method that came out of a human mind. Not just a simple method, but a good method, a good algorithm, we call it, a good procedure. So that the human mind really was going to tell computers how to solve things. The speed of a computer wasn't enough. That could do the solution, but the how to do it came from a human. And that's true to this day, but near the end of the talk, I'll talk about that a bit. So anyway, I was down there and I saw a little book called the Small Computer Handbook. Well, nobody had books on computers or knew what they were or access to computers. Oh my gosh, we didn't have a computer in our high school. And they let me take that book home. And the book described the inside guts of a computer called the architecture, holding places for numbers, instructions that told it where to add one holding place to another, ways to store things into memory and keep them in, and how to write programs, how it would work. Well, that was just the architecture of the computer. And I thought, my gosh, back in elementary school and middle school, I did all those logic designs in my science fair projects. Could I figure out how to design a computer? No books, no classes, nobody that knew how to do it. I sat down on paper, maybe for weeks before I got a final design that I thought might be the guts of a computer that was really manufactured by a company on the East Coast. And then I fell in love with this idea. I started designing. My dad got me some new lumber manuals. They were called chip manuals, because computers are made out of chips, where a building's made out of lumber. And I would study, these new chips do more than the last ones. They're better. And I started redesigning my computer over and over to make it better and better week by week. Fewer parts is better. I made up that game because I had no other game. I didn't get a grade. I didn't get told, you're done, you designed it. No, I kept trying to do better and better and better and figure out techniques other people wouldn't think of. Now I wanted to learn, see if I could design other computers. Well, Varian made a lot of computers, Hewlett-Packard made a lot of computers, Digital Equipment made a lot, Data General, a bunch of these companies, IBM. How would you get the computer manuals that describe the architecture of a computer? The top physics research place in the world, the smartest physics people in the world were working at Stanford Linear Accelerator Center. It was brand new. SLAC was brand new. I would drive down there thinking they've got to have a library, a technical library in a place like that where I can learn more about computers. And I drove in, and the guard said the main building's over there. It was on a Sunday, and I went, and I got to the main building, the door is locked, and a door is locked, and a door is locked, and a door was open. And it turns out that the smartest people in the world tend to leave doors unlocked. So I never, ever drove down to SLAC on a Sunday and couldn't get into that building, even if I had to climb a stair up to the second floor to find an unlocked door. And I'd go into the library in the car, I'd read computer magazines. And I was learning so much about new parts coming out, new computers that existed, and I could send cards in the mail to the computer manufacturers. They would send me back their computer manuals. And every weekend at my house, I wanted to close my door. My father was out, everyone was out, and all on my own, on paper, try to design this computer, try to design the next computer, try to design the C computer, and finally, one of the computers, called the Data General Nova, I decided it had a strange architecture, unlike all the others. Instead of a bunch of instructions to add things and move them around, it kind of had one long instruction that was broken into little bits of 16 ones and zeros, broken into 2 ones and zeros meant this, and 2 ones and zeros meant that, and 3 ones and zeros told it whether it was going to add or subtract or and or complement or things. Had extra little bits that had meaning. Wow, that's weird. You could combine those bits to make normal computer instructions that tell a computer what to do. It was very weird. And I sat down to design this computer, and to my shock, it wound up being half the number of parts. This was value. This what you discover is, and value in your life is going to take your own